thank Richard, Yanni, and the whole Quick team for bringing me here. So the first time I saw Quick was like 2 years ago. I think many of you are iOS developers. So when you try to search something on Google, you normally see a site like Hacking with Swift. So I was searching for iOS animation, and it got to my surprise. I saw one article from Joel. It was about building SwiftUI animations also. So I checked, then I found your website, then I saw, oh, this company is from Helsinki. So I want to thank you so much, like how you engage with the developer community, like organizing all these events for developers. I don't see any other company here doing this, which is really, really great. So I want to thank you, and today I'm going to talk about iOS animations. I think most of you use animations, and you see animations in the app you open on your phones every day. But have you ever asked the purpose and the meaning of some of these animations? So my name is Amos. I live in Espoo. I graduated from Metropolia in IT and also studied masters in Tampere University in HTI. I work for the company called Stream as an iOS developer advocate. So most of the time I speak at conferences in Germany, Amsterdam, UK, and also Italy. So when I have understanding of both design and I also have technical background. So I joined Stream in the design team and building interactive prototypes using only SwiftUI. And then for the iOS engineers, and later switched from design into developer relations. I love building interactive prototypes. So if you want to see most of the things I have been building, you can check the Twitter handle, Emojamfi, to see most of the things. Also, I like to contribute to most open source animations and projects. So the first one is Purposeful SwiftUI animations. It contains all the animation I will show in this talk. So you can find that on GitHub. There is also Spring animations. So this is like a cheat sheet which contains all the parameters about Spring animation. So you don't need to guess how to use damping, something like response or mass or any parameter for Spring animation. It is also open source, so you can check it on GitHub. There is also SwiftUI Animation Island. That is also gives inspiration about most iOS animations. Then the next is Effects Library. If you want to add iOS animations such as confetti, snow, fireworks, and fire to any of your apps, you can check it on GitHub as well. Then the last one is Motionscape. I'll go through that later in this talk. So I work for this company called Stream. It is a developer-first company based in Boulder, Colorado, and Amsterdam. And 70% of its employees are working remotely. So we provide SDKs for building chat messaging, audio and video applications. So I think many of you may want to build something like WhatsApp or Facebook Messenger from scratch, but that may take you months to do that. But using our high-level UI components from Stream, you can build it just in days and not in months. We also provide developer toolkit for building activity feeds. So I encourage you to sign up for a 30-day free trial to see how it works. Remember, we are also hiring, so you can check our website. There are positions for iOS developer, and then we also have positions for Android, Flutter, and React Native. So if you're interested, you can talk to me after this talk. I can recommend you to some of our teams, or you can also check our website. So why are we here this evening? I think you all love animations. That is why you are here. There are also bad animations in so many apps on iOS. So in this talk, I'll go through some animation best practices. Then I'll show you how to make your apps better with animations. I'll show some bad examples and some great examples. Then we go through why it is good or bad. Then I think you all want to create animations yourself. So I use SwiftUI mainly. So I'll show you how to build animations using SwiftUI. And to be able to create great animations, you need to also understand how things move. So by the time you leave this talk, I think you will understand some basic concepts of animation, such as timing, easing, and pacing. So before you start, this talk will not contain any code samples, because I think that will be very boring for you. And then I also have all the code hosted on GitHub. So you can check those animations I will show in the talk from a link I'll show at the end. So why will you need to even care about having animation in your app? So one reason, maybe you want to improve the user experience of your app. But to be able to improve the user experience, the animation you build for your app should also have a meaning, and then it needs to have purpose. So how do you do that? Let's look at this example. I cloned this from the onboarding screen from the Duolingo app using SwiftUI. So for a first-time user, once you see this animation in the onboarding screen of an app, it makes you hurry to sign up. Why? Because this is delightful and playful. So using delightful and playful animations, you can easily convert first-time users into real customers. Next, we have this example. It is just one icon changing seamlessly into another icon. So the purpose here is to communicate a state change. Next, we have this one. That is double-click to install. Once you see this animation, it draws your attention to focus on what to do next. Most of the time, we may need to explain a complex concept, such as how to set up Face ID. We can use a long text to communicate the same thing, but people don't normally read text on the interface. And if you have long text to explain how to set up Face ID, just few people will just understand how it works. So using animation, we can replace telling with showing by making a complex concept look familiar and easier. Another example can be seen in the iOS weather app. When you go to the Locations tab, you see real-time animations such as snow and rain of a particular location. So if, for example, it is raining at Espoo, you see the real-time snow or rain. So once you see such kind of animation, it makes it feel natural. It is realistic and also credible. So when creating animation for iOS, you should always aim for making the animation have the characteristics of being natural, realistic, and credible. The next is this animation. It is just a launch screen animation. We can replace this animation completely by using a rotating spinner or just a rectangle scaling up and down to simulate a launch screen animation. But here we are using the logo of a brand and also custom motion. So using your own logo and custom motion makes your app familiar with people. So another example whereby we can use animation to communicate feedback and hinting can be seen in chat messaging apps. So when you are chatting with someone, once you see this scaling ellipse, it simulates the person you are chatting with is typing. So it is time for you to wait. So we use animation here to simulate turn taking in chat messaging. In the real world, when somebody does something good, you can clap to show how you feel about what the person does. So in the digital interface, we can mimic that emotion too. This is Twitter chat. I recreated this with SwiftUI as well. So here, we are communicating with emotion. So we are using this animation to express how you feel about a particular trait. And then, when learning something new, your motivation to do it all the time depends on animation as well. So this was taken from the Duolingo app. Once you complete a lesson, you get this animation about fireworks and confetti. So for somebody that likes to learn a language, when you see animation like this, it forces you to come back again to complete another lesson. So always use animation for motivating users all the time. Here too, I cloned this Siri animation using SwiftUI. And the purpose of this is to represent an activity. So once you see this, you can see Siri is listening. So it is time for you to speak. I have shown you some great animation examples. Let's look at the bad examples as well. So this is just a rotating spinner. Its purpose is to communicate that an order has been completed and successful. But once you wait, this spins forever. This was taken from a food delivery app. It loops forever, and it doesn't stop at all. So I don't encourage you to do such kind of animation. Why? Because it makes users wonder. This happened in Amsterdam when I met my team, and then one afternoon we tried to order food. So I placed the order, and then I saw this animation just rotating all the time. So I was thinking maybe I did something wrong. Then I went to the Slack group and then noticed there are some other people complaining about the same thing. So there was a first user. He was thinking maybe he did some mistake, the same way I was also thinking. Then there was another guy who was also wondering that the order he made didn't go through. And then the one who received the order said he got them twice because they weren't sure what was really happening. So I don't encourage you to do such kind of animations. Next, we have this one. We have a slider knob. So it affords dragging to set a value. So anything like the pulsating circle animation is very destructive to this animation. So for users, this hijacks their attention. So I don't encourage you to do such kind of animation at all. Then we have this. We have a bell icon rotating at the center. If you look at this animation closely, it also ends suddenly. So this is really bad animation because it is using wrong animation parameters. So don't do this kind of animation. What can we do? When we see a bell icon, we all perceive it will be rotated at the top. That is where the hinge is. And then we can also use something like spring animation to make this animation very present. So this is what your users are mostly looking for. Next, we have this one. We have an object that drops on the screen and then disappears from another end of the screen. This is disoriented animation. Why? Because there is no mapping between the entry and the exit. So this is totally wrong. What we can do is to make the object descend and then disappear at the same direction it came from. So this is oriented animation. And this is what people are just looking for. Next, we have this one. Here, we are using spring animation to create merchant ant effect. The animation is animating with spring, and then it doesn't even make sense here. So I don't encourage you to do that as well. What we can do is to change the easing function to something like linear so that we get seamless looping animation. And this looks nice to the user. So, to be able to create great and good animations for your app, you need to learn some basic animation principles. There are so many kinds of animation principles. So let's look at the basic or the key animation principles you can adopt for your next app. The first is this one. We have a card that transitions from thumbnail state to a full screen mode. But look at it closely. Before it jumps into full screen, there is also a subtle scale down animation. So this is called anticipation. It gives a sense of what is about to happen. So what is about to happen in here? That is the full screen animation. So it scales down before it jumps into the full screen mode. This was taken from the App Store. And then how do you create such kind of animation? You cannot create this animation using the standard easings. So what we can do is to use a custom easing. Here we have ease in, out, back. Once you see this screen, your eyes focus on a number changing from one state to another state. There is also a circle animating as well. This is called staging. So using the principle of staging, you can direct users' attention to focus only on what is important on a particular screen. You can use this principle to animate numbers. For example, if you're creating a countdown or count up timer, you can use the principle of staging. Staging is great because if I have a number that changes, for example, immediately from 0 to 100, it is easy to miss what just happened. So using this principle, you make the user see how a certain value changes from the initial state to the final state. Next, we have follow-through animation. Looking at this object, the background animates with spring animation. So using spring animation, we follow the principle of phases to create soft and imprecise movement. So using springs, we can make an object overshoot its resting state all the time. So how do we create spring? We have several parameters, but those that worth mentioning is the mass and the damping. We can use a large value for mass to create overshoot. We can also use a very small damping to create the same effect. Next, we have this text. When we start to drag the text, the individual characters appear as if they have a loose connection with the main motion. So what is the main motion here? That is where the drag ends. This is called overlapping action. So when you have similar elements animating in the same way, you can offset their begin time to create this cascading effect. To do this, you can animate the first element to have a delay of, for example, 0, and then the one that follows should have a delay of, for example, 0.1, and the others will follow as well. So let's move on now to the real world. When objects move, they do accelerate and decelerate. That means most objects will increase their speed, and then for some time, they will also decrease their speed. In the digital interface, we can mimic those movements using what is called easing and springs. So using springs don't depend on time, so they are very difficult to work with. So most of the animations you create will be using just easings. There are several kinds of easings in core animation, but those that we're mentioning are these ones. Let's begin with linear. Here we have an object that animates from one location to another location. But looking at this animation, you can see it is moving with a constant speed. So this means there is no change in speed at all. So we don't have acceleration or we don't have deceleration as well. So the absence of this makes this animation look mechanical, and it is not natural at all. So you may ask, then why do we have something like linear? We have it because it has its own space in the animation landscape. Here, I cloned this from the Yahoo Weather app. We have a fan icon that rotates constantly without the speed changing at all. So if you want to create something similar to this, the best kind of easing is to use linear. This is heart rate measuring. You can find it on Apple Watch. I also cloned this using SwiftUI. Here, the object is also animating with constant speed. So using linear makes sense here. There are more application areas where you can use linear. For example, if you want to create time-lapse animation, opacity animations, color changes, and camera effects. The next is ease in. With ease in, the object starts slowly, and in the end, its speed will increase. So the velocity of the object changes over time, and that increases over time. So we can use ease in to create auto-initiated animations. That is, animations that do not require any user interaction. You can also use ease in to move objects away from the screen. But one thing you need to consider when using ease in is that you don't use it to animate opacity and scale, because it makes the animation end suddenly, like the bell icon animation I showed previously. So one application area is here. I use it to move the object away from the screen. Since the object is losing attention, it makes sense to use ease in. Next, we have ease out. With ease out, the object will start quickly, and towards the end, it will slow down. So its velocity decreases over time. One way to use ease out is to move objects onto the screen. So this is opposite to ease in. When you're creating human-initiated interactions, the best easing to use is to use ease out. Here, I'm using this to move the object onto the screen because it is gaining attention. There are more application areas. For example, if you want to create button taps and page-to-page interactions, you can use ease out. Then we have easing out. With this, the animation will start slowly to attain a very high velocity in the middle. And towards the end, it will slow down again. So if you compare this to the real world, this is how most objects move. Let's take a look at the movement of a car, for example. If you start a car, it will start slowly before you attain a high speed. And once you come to a destination, you need to slow down again before it can come to a gentle stop. So using ease in out, you can create on-screen animations. For example, creating the ping pong effect, where you have an object that animates from one location on the screen to another location on the screen, which is called to and fro motion. Here, I use it to clone the calm up animation, that is brief animation. So here we have two objects that animate with scale and rotation, and both animate right on the screen. So using ease in out makes sense in this context. The next is default. So here, the animation starts quickly to attain high velocity, and towards the end, it will slow down. So this is quite similar to ease in out. The only difference is with ease in out, the object will start slowly, but the end state of both easings are the same. They will slow down in the end, and in the middle, they will increase their speed. So if you want your animation to mimic most system animation on iOS, watchOS, tvOS, or macOS, the best easing to go for is to use the default. So it is great for creating on-screen animations as ease in out. Here I use it to animate the number and also the circle as well. So most of the time, the kind of effect you are looking for may not be found using the custom easings. Using the standard easings, this is where the custom easings come in. So this uses mathematical expressions to simulate how objects increase their speed and reduce their speed as well. So if you want your animation to have unique look and feel, what you have to go for is to use custom easing. On iOS, we have several kinds of custom easings, but I have categorized them into 4 categories. And under each category, we also have different examples. So let's begin with sinusoidal. Looking at this graph, it is just similar to ease in out. So the object starts slowly to attain a high velocity in the middle, and towards the end, it will slow down. So this is great for creating gentle animations, like ease in out. One great example is the gentle bubble effect in iMessage. With this example, we have an object that starts slowly, but towards the end, its acceleration increases. So you can use it to create an animation that has dramatic acceleration. One example is the slam bubble effect in iMessage. Sometimes you want your animation to feel fast, energetic, and also exaggerated. One example here is to use the bubble is to simulate something like the bubble effect in iMessage. The final example to show is ease in out back, and I categorize this under special easing. This is a combination of ease in and ease out. But looking at the graph closely, you can see the start and the end positions go beyond ease in and ease out graphs. So when do you use this? Like the App Store card animation I showed previously. Here I use it to transition an image from a gallery into full screen mode. So if you want to create something like anticipation effect, like I showed previously, here the image, before it jumps into full screen, it scales down slightly before the actual motion. So to create an effect like this, you can use ease in out back. So when creating these animations, there is also no way to visualize the easings, whether it is the standard easing like ease in, ease out, or ease in out. So luckily, we have this app called Motionscape. I built this with one of my colleagues at Stream. So what it does is you can use this to preview all the standard easings and custom easings for SwiftUI animations. And then once you are happy with the adjustments you do, you can easily copy the code for your SwiftUI animation. So I encourage you to try that. It is an open source application, so you can find it on GitHub and in the Mac Store as well. When creating animations, another parameter you can just use to create great animation is timing and pacing. So what is timing? It is the time between the initial state of the animation and the final state of the animation. So in other words, it is the same as the duration of the animation. Pacing, on the other hand, relates to speed. So it is the speed at which objects animate. Using these 2 parameters, you can easily describe great animations from very terrible animations. So when creating animation, you should bear in mind not to make the animation very slow or faster than how it is supposed to be. So you may be asking, how long or how fast should an animation be? This is where you can use something like duration sets. So you can create different durations for the same animation. For example, you can have immediate, fast, slow, and intentional. Then you can test which one of them works best for your animation. Another parameter you can use to create great animation is mass and weight. So what is mass? It is the same as the weight of the object. It changes the object's inertia. So what is inertia? It is the tendency of an object to remain in its state of rest or uniform motion. In other words, it is its willingness to move, and when it is already moving, it is its willingness to stop moving. So using mass, like a large mass, you can overshoot the resting state of an object. Let's look at this example. I cloned this from Facebook Messenger. It is reaction animation. So it shows different kind of mass. If we change it to a large mass, we make the object very heavy. So when an object is heavy, it is very difficult to move. And when it is moving, it will also be very difficult to slow it down. If you change it to a very small value, then we make it lighter. And lighter objects are faster to move. And when they are moving, it is also easy to slow them down. So let's look at some animation best practices. When creating animation, you should always aim at making the animation become nimble and precise. So in that case, you can convey information more effectively. Do not keep users to wait longer than how they are supposed to wait. For example, when having loading animations, like the one I showed for the food delivery app. When creating animations, you should also follow some basic accessibility guidelines. For example, there is no need to have too much flashing animations because those animations can cause headache and seizure for people with motion sickness. So you shouldn't use excessive animation at all because they also cause discomfort and dizziness. For example, if you have too much parallax scrolling and sliding animations. And one accessibility feature you can add for your apps is reduce motion. So what is reduce motion? It makes users disable the animation they don't want to see in your app. Here I created spring animation, and once I turn on reduce motion, the animation is replaced with shadow animation effect. You can also make users disable the animation completely. So it depends on you whether to remove the animation completely or to provide a shadow animation effect of excessive animation. So how do you do that? In SwiftUI, you can access this via the environment accessibility reduce motion. One example of where reduce motion is used is in the iOS weather app. We have location animations such as snow and rain. And once you turn on reduce motion, these animations are completely disabled. So you don't see any animation at all. Another example can be seen in Telegram. In the Telegram app, when you long press a chat bubble, it shows spring animation. This can be turned off by going to the settings. So once you do that, it removes the animation completely. Another great example can be seen in pCalc. This is a calculator app. Once you type on the number, it shows scaling animation for the numbers. But reduce motion doesn't remove all the animations. So what you can do is to implement such effect in the settings on your app. In pCalc, you can go to the settings and remove the animation completely. So once you do that, you get a fade effect instead of the scaling animation of the calculator buttons. So when creating animation, you should also aim for using system components because they already include motion. They provide familiar and consistent user experience. And most of the time, you may need custom motion for your app. In this case, you should try not to overwhelm the users all the time. You should use motion or animation to keep users oriented and use animation to provide feedback to users' actions. So you may ask, how do you create such animations? You may have a static asset in a tool like Sketch or Figma. So one thing you can do is to move the static asset to a timeline tool. Here I use Kite Compositor. And then after moving it to animate the object in a timeline tool, you can recreate such animations with SwiftUI. I like using Kite because all the animation parameters are also the same as the animation parameters in SwiftUI. For example, on the right, I'm just animating the dash face of the heart icon. So it moves the open path along the heart icon. And the same property is also found in SwiftUI. You can also use animation tool like Rive, but I know some people also use Lottie files, but I don't encourage that because the smooth animation you may create in After Effects may be totally different from the one that you add in iOS. So you can use Rive to create some of these animations. And once everything is ready, you can now just build it into the actual app. So to recap, the most important principles you can adopt to create great animation is to implement basic accessibility guidelines. You should implement reduce motion so that users can turn off the animation they don't want to see in your app. Always make the animations nimble and precise so that this can convey information more effectively. Don't keep users to wait for a longer time than how they are supposed to wait. And when creating this animation, you should always define the goal and the purpose of the animation. So this can be just asking some basic questions. One is, does this animation provide any useful information? What emotional response does it convey? And then, is it supposed to establish relationship between elements? And what about if the user turns on reduce motion? Do I need to disable the animation completely, or do I provide a shadow animation instead? You can use Spring animations any way you want, but you need to make sure that Spring animation makes sense in this context. You should also avoid using excessive animations for frequently occurring interactions on iOS, such as navigations, tab bar, and also list items. So before we leave, I would like to tell you that anytime you animate, you should think before you animate. I have all the animations I showed in this talk, in this GitHub repository, Purposeful iOS animations. And then there is Spring animation cheat sheet that shows you all the parameters about Spring animation. You can find it on GitHub as well. And the others are also about iOS and SwiftUI animation. You can find all of them on GitHub. And these are some of the links I used for this talk. You can find all the slides on Speaker Deck. And from my team, I would say thank you very much for spending time with me on this talk.
Right, thank you so much, Hamos Kiampi. Let's take a few minutes break just to grab a drink and let our next.
But before that, I think we should. Do people have any questions?
Oh, questions. All right.
How do you feel about the responsibility of animation? So, in many teams, you have a designer and a developer. How do you see the responsibility with the animations? Because you said think before adding animations. That sounds like if you feel like you want to add an animation, you should think, but can it be other way around as well?
So in my company, I just create most of the animations for our sample apps. So what I normally do is I have to, like if some of the engineers request animation from me, I don't start immediately. I have to ask the designers whether this makes sense or not. Then I try to ideate with the designers, and based on their input, I just recreate it with SwiftUI. So if you do something like that, like if you have a designer who can just mock up some of these animations for you, I think it makes sense to start from there.
Yeah, but you said that the developers would initiate the animation request.
It depends. We already have some apps, so if anyone requests those animations, I just need to contact the designers as well. But most of the time, it will be initiated by the designers by themselves. Yeah.
Any other questions? That was a kind of empty presentation then. Super interesting presentation, and I think I was watching Richard completing his presentation and his request for being the last presenter of tonight. So could everybody please ease in and ease out to the beverages and pizza?
Good.
Let's have a 10-minute break, and then Andre will be discussions about comparing the SwiftUI, UIKit and Flutter, and Richard will be the last presenter